Okay, I'm going to finish up section 5.6 now. We're looking at logarithmic equations and exponential equations. In the previous video, I solved a bunch of logarithmic equations, and so now we'll turn our attention to exponential equations. Now, we've already solved some exponential equations earlier. We did that in section 5.3, but we were kind of limited because in those problems, the strategy was to try to get the same base on both sides. Okay. Now, you're not always able to do that, so there is more to know here. But like in this example, if I want to solve the equation 2 to the x equal 8, I know 8 is the same as 2 cubed, and I've got base 2 on both sides, so I can remove the 2's and set the powers equal and have x equal 3. 2 cubed is 8. Okay, so a problem like this isn't so bad. And by the way, you don't need to check your answers with an exponential equation if you don't want. That's only for the logarithmic kind in this chapter, actually. Okay, so take note of that. So a problem like this isn't so bad, you know, because really all you had to know was 2 cubed is 8, and you're practically right at the answer then. But what if I want to solve 2 to the x equals 7? Well, now the problem becomes more difficult in that 7 is not a power of 2, like 8 was a power of 2. So I'm not going to be able to easily get the same base here on both sides. Whenever that happens, you want to consider getting logarithms into the calculation. Now, in particular, we prefer to use the natural logarithm. I'll comment on that in a later problem, although you can use any base if you want. And so I'm going to go ahead and take the ln of both sides. Of course, I can use my laws of logarithms now, right? I know powers can come out of logarithms, so this power of x can come in front of the ln of 2. ln 2 is just a number, so divide by that number, and that way x is all alone now. And you've got ln 7 divided by ln 2, which if you were to go to the calculator and type that in, I was getting roughly 2.81. By the way, that at least sounds reasonable to me. Based on this previous example, 7 is a little bit smaller than 8, and we had x equal 3 there. So, you know, before I did any calculation, I probably could have expected x to be a little bit less than 3, and that's exactly what happened. Okay. In fact, this is the right answer. Now, here would be another way that you could do the problem. So you have to do things with logarithms. You don't have to use the natural logarithm, although that's kind of a preferred option, or base 10 is also preferred. But like, what if I were to take log base 2 of both sides? Okay, well, the power of x can still come in front of the logarithm there on the left. Log base 2 of 2 is 1, so I'll have x times 1 is x. And on the right, I've got log base 2 of 7. Now, log base 2 of 7, that would be the exact answer. But if I wanted to know what that would look like in a decimal form, I would have to change the base, right? Because on my calculator, I don't have a log base 2 button. I've got an ln button and I've got a log button, but I can't do other bases. You know, most calculators don't have that option available. So I would have to change the base to a new base, and I'm using the change of base formula. I'm changing this so that it's base e. Using the change of base formula, log base 2 of 7 becomes ln 7 over ln 2, but that's exactly what we had over here when we just used the natural logarithm to begin with. So to me, it makes the most sense to just use the natural logarithm to begin with, because otherwise you got to change the base at the very end, and that kind of sounds like a silly thing. Here's another example. I want to solve for x. So the bases are not going to easily match up. Like, there's no easy way to rewrite 5 as e to some power or e as 5 to some power. All right, so again, I'm going to have to use logarithms here in solving. I'm taking the ln of both sides. That allows me to bring the power of 2x in front of the logarithm on the left. 2x times the ln of e. The ln of e is 1. And so that's going to leave me with just 2x there on the left. We've got ln 5 on the right. Divide by 2, so x is equal to the ln of 5 divided by 2. That'd be the exact answer. And if you were to go to the calculator and punch that in, roughly 0.805 would be that number in decimal form. Now, pay attention to how the book wants the answers written. Okay, sometimes they might want the exact answer, and sometimes they might want the approximate form, and they would tell you what a round in that situation. Okay, but be sure that like any other math problem, make sure that you're reading the directions there for how they want the answer represented. Now, here's another reason why we usually use the natural logarithm. I mentioned that base e is the most common base when you're working with exponentials, and so if you're using the natural logarithm, the ln e is 1, and of course it makes sense to be working with a multiplier of 1 rather than some other number, so it's just really for ease of the calculations in that regards too. Okay, here's another example. I want to solve for x. Now, again, I'm not going to be able to easily get the bases to match up. I won't be able to write 3 as 5 to some power or 5 as 3 to some power. Okay, so I want to begin by taking the ln of both sides. That will allow me to bring the powers in front of the logarithms on both sides there. Now, I would also add that when you bring the powers in front, include parentheses around those expressions, just because we're going to want to distribute ln 5 into these two terms on the left, and then ln 3 into these two terms on the right. Okay, and so that's what I've done on the next line here. I've distributed. And anything involving x, I'm getting that on the left, so I'm going to subtract 3x ln 3 from both sides, and I'm going to add 2 ln 5 to both sides. X is in common to these two terms on the left, so I've factored that out. And that leaves me with ln 5 minus 3 ln 3 inside the parentheses. ln 5 minus 3 ln 3, that's just a number, like, 2 is a number. So divide by this number here, and that way x is all alone. And I've got x equals 2 ln 5 plus 2 ln 3 all over ln 5 minus 3 ln 3. That would be the exact answer. If you were to go to the calculator and punch that in, you'd get negative 3.212 if you go nearest 3 digits on that. Now, if you type in the whole thing all at once, you would want to make sure to have parentheses around the numerator and parentheses around the denominator. That way that your calculator knows to divide at the very end. If you don't have the parentheses, you won't get the same number that I'm getting there. That would be the correct answer. Okay, and I've got one more example here. Again, I'm solving for x. This is an exponential. If I subtract 50 from both sides, 21 minus 50 is negative 29. Divide by negative 3. Negative over negative is positive. And here's another situation where I'm going to want to take the ln of both sides, right? 29 thirds, there's no easy way to rewrite that as 0.78 to some power. And same thing over here, 0.78, there's no easy way to rewrite that as 29 thirds to some power. So we'll take the ln of both sides. That allows us to bring the power in front of the logarithm on the left. Again, make sure that you include parentheses so that when you distribute ln of 0.78, it's going to go into both of those terms there on the left. Then you're going to add 10 times ln of 0.78 to both sides and divide by ln 0.78. That way x will be all alone there on the left. Okay, this number here would be the exact answer. And again, if you were to go to the calculator and punch that in, here would be the approximate decimal form rounded to 3 digits. Okay. Again, if you're going to type in the whole thing all at once, you'll want parentheses around the numerator and the denominator there. That way your calculator knows to divide at the very end. Okay. It'd be a good idea to maybe try using your calculator to make sure that you're getting these numbers. Okay, obviously if you're not getting those, it's a mistype, but it's probably a parentheses issue. And if you're still having, if you're not getting them, let me know. But all right, so that's it with section 5.6. Here's the homework problems that I'd like you to look at on page 478.